Hello students, this is lesson U7A01. By the end of the lesson, you should be able to say, I can find the area of a regular polygon. So to approach this, we're actually going to just jump right in and try to find the area of a polygon. In particular, we're going to start by finding the area of a regular decagon with a side length of 4 inches. So what exactly is a decagon? A decagon is a polygon with 10 sides. So what's the strategy here? We're trying to find the area is the space that's inside of this enclosed figure. And if you recognize that all the sides here in this regular decagon are all the same length, therefore, if we were to connect the dots between all vertices, you're going to see all the opposite vertices, that is, you're going to see that we actually have a series of different, not different, we have a series of the same isosceles triangle. Okay, the angle on the inside there, okay, it's the order of magnitude of reflection. Remember that from going back in the I think unit 2, okay, where we talk about reflections and rotations, okay, or rotational symmetry. The magnitude of rotational symmetry here would be 36 degrees, because if we rotated this 36 degrees, it would land on itself exactly the way that it is shown right now. So if we were to try to find the area of this decagon, if we find the area of one isosceles triangle and multiply that by 10, we would essentially solve the problem. So that's the approach that we're going to take. So by connecting one vertex with the opposite vertex, we form two congruent isosceles triangles. And we need to find the area of that. So we to find the area of this, well, I don't know how to find the area of an isosceles triangle, but I do know how to find the area of a right triangle, and that's the approach that we're going to take. Theta in this case, okay, because this, we're calling that theta, so therefore this is going to be half theta. So therefore this must be, that angle there must be 18 degrees, because the overall angle is 36. So recognizing that the angle is 36 degrees and half of it is going to be 18, I can take tangent, because I have opposite to adjacent. I can solve for what A is to get the height of the triangle to then find the area of the triangle. So tangent of 18 degrees therefore is equal to 2 over A. A therefore is equal to 2 over tangent of 18. Or A is approximately equal to 6.1554. So now that I have what A is, I can then easily find the area of that isosceles triangle by taking the height and multiply it by 4 and dividing by 2. And then I need to multiply by 10 to get the area of the entire decagon. So that comes out to approximately 123 units, 123 inches squared. Let's try to find the area of a regular octagon inscribed in a circle with a radius of 4 inches. So the presentation of the problem is slightly different. This time I have a regular octagon and it's inscribed inside of a circle. So we draw a circle all around it. And it's saying that the radius of the circle is 4 inches. So what does that mean? That means if I connect the center to the vertex, those sides are going to be the length of the radius, which also happens to be the legs of the isosceles triangle, just like in the previous problem. So therefore, what I now recognize, again, going by the same approach, this overall angle is going to be 360 divided by 8. And I have half of that angle. Okay. I don't know what the side length is, okay, but I'm calling that S. So therefore, this side here is half S. So this is the situation that I have. The radius is 4, and the number of sides is 8. I recognize that that is 4, okay? The radius is 4, and theta, therefore, is, in this case, is going to be half of 45. So it's 22.5. So what I need to do because I am given the radius, which in this case is the hypotenuse, and I need to solve for the height again. That height happens to be adjacent to theta, so therefore I'm going to use cosine. So a over r is equal to cosine of theta. Substituting in the things that I know, I'll end up with a is equal to 4 times cosine of 22.5. Thereby, a is approximately equal to 3.6955. If a is approximately 3.6955, then I can find out what is the base by, again, using either the Pythagorean theorem or trigonometry. I need to know what is the length of that base. So how am I going to do that? I'm going to use more trig. So I know that half s over r, half s is the opposite side, divided by the hypotenuse is equal to sine of theta. Now I'm going to solve for what s is. I already know what r is. R is equal to 4. Theta, once again, is 22.5. All I got to do is solve for s now. So s is equal to 2 times 4 times sine of 22.5. So therefore, s is equal to approximately 3.0615. So now I have my height and I have my base. I want to multiply base times height, divide by 2, and I want to multiply that product by 8 because I have 8 of these isosceles triangles. So therefore, the area is approximately 45.2551.